In this video, we are going to study continuous cumulative distribution function. Definition is following. Like in the case with discrete random variables, cumulative distribution function shows the probability that my random variable is less than some value. Notation is following. Uppercase F, subscript name of our random variable. It's a function of some value x, which shows the probability that my random variable x is less or equal some value small x. Now, in the case when we are working with continuous random variables, this value calculated as the following indefinite integral from -infinity to the value of small x. Integral of our PDF function for random variable x. So we are calculating the probability that our random variable x lies to the left of some value small x, which is calculated the area under the PDF curve. Now let's take a look at a couple of useful properties. First property is first derivative of CDF is going to be equal to the PDF of that function. Now let's take a look at a couple of useful properties of CDF function. So first derivative of CDF is going to produce as PDF of that random variable. So if we take derivative of indefinite integral defining CDF, then according to the fundamental theorem of calculus, this is exactly equal to PDF of that random variable. Now, since a total of 1 unit of probability is assigned over all real interval, over all values of x, which means that if I am looking for probability, let's call this by different name, for instance, P. If we are looking for probability that my random variable lies to the right of some value small b, then it can be defined as 1 minus probability of x being less than b, which is exactly CDF of random variable x at point b. So if I'm looking at the area to the right of that point b, then since 1 unit of probability assigned over all real interval, it is going to be equal 1 minus area to the left of that point. Now, our next property is if we are looking for probability that my random variable x lies in between some 2 points, let's say A and B, then it can be found as the following difference. So let's assume that here are my 2 points A, and here's my point B. If I am looking for the probability of my random variable being in that interval from A to B, then it can be found by subtracting the following two areas. Areas to the left of point P, or probability that x is less or equal than b, minus the following red area, which is probability that x is less or equal than a, which is equal to CDF at b minus CDF at a. Now, I'm not paying much attention to the sign of equalities here, since we know that probability of continuous random variable x being equal to some specific value small x is equal to 0, meaning that if we have a strict if we have probability for random variable x being strictly less than some value a, it can be defined as probability x being less than a plus probability of x being equal to a. And since that value is equal to 0, I can work with strict inequalities being the same as non-strict ones. Now let's take a look at the following graph of PDF. Let's select an arbitrary value for small x on x-axis. Now if we're looking for the following limit as x goes to plus infinity of CDF at point small x, then it is going to be equal to 1. So if I move my arbitrary value of small x to the plus infinity, then we are looking for the value of the following limit, and which is equal to 1. If we are taking limit as small x is approaching to minus infinity, then as you might have guessed, if we are scrolling that x to the left, then that limit is equal to 0.